So for your first one, what do you guys think the amplitude is?
2 divided by 2 over 2.
2/3. Perfect. That's it. Okay. If you guys get an amplitude question, it's that easy. You're just going to look for whatever the beginning part is, whatever the A is, the number that comes before your sine or cosine.
That's really easy.
Yeah. So example 2, what are you thinking?
Ratio is part 6.
2? Nice. A part 6? I don't think so. 2. Good job. Same deal. Amplitude, just the sine and cos. Now, for the period, this is probably the most common thing I see being asked of you guys. If they ask you guys what the period is, it's difficult because you need to make sure you know the formula for it. Oh, so I missed 3. I'm sorry. Thanks, Allison. Oh, yeah. Well, let's skip 3 for right now. Let's talk about the period first, then we'll go back. That's a hard one. What do you guys think for the period? What would you want to use? What do you need here? The b. Good job. Very nice. Because in order to do the 2 pi over b, we need to figure out what the b is here. What is the b? Great. Good. Nope, that's a pretty common one. Yeah. Great. So your frequency is just whatever this is. If you can reduce, reduce. If you can't, that's it. 2 pi over 3. That's what the frequency is when it's b. Why don't you guys try this one? What do you guys want to place for b here? 1/3. Awesome. Yep. B value 1/3. Good job, Lorison. Copy, change, flip. Very good. So turn to the complex fraction. And when we flip this, okay, 3 times 2 is going to give us 6 pi. What do you guys think about that one? Not bad for fraction? Okay, cool. All right. I'm going to come back. I want to do some, I don't know why I put this so early in. We're going to do this one like last, because it's this is probably the hardest type that you guys can see. Oh, actually, what is this? Never mind. I thought you were going to make us, you could do this one. Sorry. My bad. I didn't read the question. I thought you'd have to tell me what the curve like the equation was. All right, so this one says, what is the amplitude of the function? Bless you, bless you. So amplitude, you got to be really careful here. Is this supposed to be like our normal sine curve? It's our normal one. When you guys had a normal one, it started at 0 and went up, down, and around. Right? That was like a normal curve. And we had the same space on the top and on the bottom. So how can we figure out what the amplitude is in here? What would you guys want to kind of draw or do? Good, Carly. Line down the middle. That's the big thing. Because right now, this isn't starting at 0. It was moved up 4 spots. So Carly said, let's draw a line down the middle. I love that. Okay. Well, now we can figure out what's the distance going on in here. 2. Good job. If you're going from 4 to 6 or 4 to 2. Right. The amplitude in here is going to be 2. Good job. That was great. You see how they can be tricky with that kind of stuff? If it doesn't like line up at 0, it's like moved a little bit. So just be careful. Amplitudes always want to split it through the middle and look up and down. Right. Okay. So if you guys see a shift, I know I told you yesterday the horizontal, like I never see questions with that come up, but maybe a vertical one. This one's a little bit tricky. So it's talking about a path of a roller coaster is modeled by an equation. Right? You like to know how your roller coasters are kind of wavy, so that's why they did a sine curve. What is the maximum altitude of the roller coaster? So they want to know what is the maximum height of this roller coaster going to be. I want you to stop and think about it for a second. Don't yell it out. Just think about it. There's a little bit extra stuff going on with your equation, which will impact things. Okay, so a couple things in the start. What's your amplitude?
27.
27, good. Now this, we have some extra stuff. When you have something being added or subtracted at the end, does anybody remember what that part controls?
The height.
The height, the up and down. This is a vertical shift. So what they're saying is, all right, well between, we don't need an exact kind of curve here. Our normal sine curve, this is saying it's going to go all the way up and down to 27. There's 27 units in here. But this is a little tricky. It's not just going to go to 27 because originally we were taking this picture and we were moving it up. Yeah, we were moving it up 30 units to start. So it wasn't even starting till 30, right? So if you're looking at what the whole height would be now, it would really be 30 plus that 27 inches that's going up, which would make 57. So a lot of you guys are right. It's just saying
30 will be like where you start on the y-axis.
Yep.
So that's what happened with the other one over here?
Yep, exactly. That one's hard to do an equation. Andrea just asked me about it because your x-axis isn't nicely labeled in terms of pi. So we can go back to that one and make an equation again if you guys want, but I'll change the axis for you a little bit. All right. The other way I see this come up a lot, besides just period questions, are when you guys are matching things, like matching equations to graphs. And this is where your calculator could be very handy. Also, you want to pay very close attention to the axis, because that's where they may try to trick you. Okay, sometimes they don't always go to 2 pi, they might just go to pi. Okay. And we want to look at all the different components, what the amplitude is, what the period is, what the frequency is, to kind of help us with everything here. So sine curves, guys, always start at 0. So that's what we're talking about today, so I put all of those sine. Now, first thing I would look to do is figure out what your amplitude is, because that's the easiest thing to recognize and the easiest way to kind of take away a part. What do you guys think the amplitude is here? There's 3. 3. Okay, good. Perfect. Right, yeah, if you want to split it down the middle, look up, look down, there's 3 of them. Right? So right away, anything that has an amplitude of 3 is going to be good. I'm going to get rid of 4, I'm going to get rid of 2. It cannot be that. Now, the thing that's going to help us again is the b value in here. Right? You have different b values. So we really need to understand, what does the frequency show you? How many full curves are between what? 0 and 2 pi. Good job. So if we look, here's your 0, here's our 2 pi. Let's check it out. We have 1 and then 2. So the b value needs to be 2. That's your frequency. And so it has to be choice 1. So all those little parts are pretty, like, you know, important here. Now, if you use a calculator, we could check. Right? So if you have a calculator, take it out. Oh my goodness, it's transferred. Make sure you guys all remember how to put stuff in here. What mode do we need to be in for graphing? Good, radian. So just make sure, check out radian mode, make sure that's highlighted. Okay. Now when we go to our whiteboard, if we wanted to make sure that we were right with what equation we picked, right? Let's type in 3 sine 2x. 3 sine 2x. Okay. And if we graph this, if your graph is not coming up with those big intervals, or you have to hit zoom 7. Zoom 7 gives you guys the interval. All right. Now, this isn't 0 to 2 pi. This right here is your 0. So here's your 0. This was your pi over 2. Here's your pi. This was the 3 pi over 2. And then this one was 2 pi. So look to see, does that look, when you just look at this part here, does it look like what your picture is?
Yeah.
Yeah. And you can kind of check to see that it's hitting in good spots. Right? Here was your pi, it hit at 0. Add the pi over 2, it hit at 0. So check out your calculator. Right? At the pi over 2, it's at 0. The pi is at 0. So you can kind of like make sure it hits at the right spot. So matching things up with the calculator is kind of nice to make sure you guys get it right, but you want to be able to do it both ways. Is everybody able to enter this in okay? Yes. All right, why don't you guys try the next one? This one's a little bit more difficult. Maybe we can come up with a conclusion based on this. Again, use your calculator for some help. If you're not sure what's going to happen, try it out. Try to type it in. See if you can match up which one it's going to go to. Yeah, but someone else yesterday was going through like, what if the amplitude is 100? Oh, on here? Yeah, it's going to be more that we did. I'm going to show you guys how to make intervals. Yeah, there's like, you gotta make sure it's good. I'm going to show you guys how to do it. Just hold on, okay, so here's your zero. Here's your zero. Oh, it's a different one? Alright, let's put it there. Yeah, so you just wrap that in one. Right. Okay. So a couple of these, hopefully we can get rid of at least. This is a little bit tougher. What's your amplitude? Ooh. Right. Well, yeah, the amplitude is still going to be 2, but I like what you guys were kind of saying here. What do we know? What did you guys kind of decide, I think, when your graph went down? What did it have to be? Yeah, it had to be negative in the beginning. Right? So that's something that you guys are going to see a lot. If you ever start your curve and you go down first, your sign has to have a negative in front. It's going to be like a negative value in the front of it. And then how many full curves did we see between 0 and 2 pi? Just one. Good. So the b value has to be a 1. We need either one of these. But since it had to be negative, choice 3. And again, can you graph that and see if it matches up? Yeah. All right. So use your calculators for some help. This is something I see come up quite a bit. All right. The matching thing. Right. They're not too hard. Something I never see come up in Regents anymore. They used to do it way back when they taught Math B. I've never seen it on yours. So I doubt you'll ever have to graph something like this. But just in case. So if they ever ask you guys to physically graph a trig graph, okay, there's a couple things that will help you, all right? Now, we need to make sure we put some scales on here. Right. What's your amplitude going to be for this? 3, okay. So, well, we know that amplitude is going to be 3, so let's use that for some help in making a scale. The amplitude is the tight part. So, do you guys want to make little baby ones? Or can we skip a couple? Kind of make multiple intervals. Yeah, we can do a couple blocks, right? So let's make this one maybe 1, 2, 3, 4, just so you can get an idea. -1, 2, 3, 4. Okay. Now the tough part about this is I think the x-axis, because when you guys use trig graphs, we're not in degree mode, we're in radian mode, so everything's got to be in terms of pi. What this part shows you guys is that we only want to see between negative pi and positive pi. So when we are graphing, this is your 0, and especially on the x-axis, I would skip like 3 blocks probably between each part. Or you don't want to do 1 because isn't it hard if you guys were trying to draw a curve to make like a full curve between 1 block? Like it's very tight. So we're going to skip a couple blocks. When we're graphing on your x-axis, what we're going to be modeling is, do you remember how we did the 90, the 180, yeah. Right? And then we did 270, 360? Oh, is that what the pi? That's what the pi, exactly. So how here, we only want to go from negative pi to positive pi. Does anybody remember what the 90 was? Pi over 2, good job. Right, what's the 180? Pi, good. Now if you're going in the negative direction, this is like negative pi over 2, and then negative pi, right? Negative 90, negative 180. Does that make sense? All right, so what we're going to do is graph this thing by using these intervals, right? And I would skip like maybe 2 or 3 blocks between. Yeah. Oh, just because, well, if you have anything, you go to okay. So do you remember how we always had, oh, I erased all the other things. Like this was your 0, 360, your 90, 180, and the 270 from the unit circle? If we don't usually use degrees when we graph, it's always radians. So if you change like 90 into radian form by multiplying it by pi over 180, it would reduce to pi over 2. You're using the big spots of the unit circle because if you looked at what the signs were at those points, like when you had 0 degrees, your sign was 0. So that's why you have like a 0 here. If you, this is just a basic curve though. We have some more stuff going on in the one we have. And then at the 90, you have to go up to 1. So that's why pi over 2, this is like the 90 part. Right? It kind of gives you like a map of like where you should be. So usually use like pi over 2, 3 pi over 2.
Why can you do that? Like on a graph, like 1, 2, 3, but how can you just like use degrees?
It's more because I don't think how to explain this. I'll look up a good thing for you. It's because when you guys are modeling things in a trig graph, we just don't use degrees in upper level math anymore. Once you guys get to this part, you're expected to do a lot more radians. Like, I know Miss O'Malley, she won't even do like the conversions in pre-calc. It'll just be always in radians. More because too, if you try to graph on a, okay, let's say I tried to graph something and I was not in radian mode, okay? This might make more sense. I'm in degree mode and I try to graph a trig graph. Does that look like what we should have? No, it comes up to be like a line. So if you're doing things in degree mode and having like degrees or something on the other axis, it doesn't like show up correctly. Like, so it's more all in radians. I'll ask around and kind of get a better explanation for you. But you just always want it in radian mode. Good question, Andrea. Then when you graph it in radians, it's like 80. It's kind of like what you really want. Julie, did I answer this part kind of?
Yeah, I guess. I just confused it. I mean, I get that you have like how they go along.
Okay. I don't think how is the thing. I don't really know. I'll see if there's any kind of good explanation. So I think that's the same. You guys are on the same boat with that. Oh gosh, where's the last thing? Is it at the end? One more forward? Oh, there it goes. Sorry. Thanks. Okay, so let's go back to this part. The reason why you want to go only to 180 is because pi is 180. If you had 2 pi, you would go to 360. Like if you more spaces. Right. So here we only have 2 intervals we need to show. So I skip a couple blocks. Right. Just make sure it's consistent. Whether you do 2, whether you do 3, whether you do 4 between. It's just got to be the same. So there's my pi over 2. Here's your pi. Alright, and then negative pi over 2, negative pi. Alright. Okay, so if you guys are going to be working with this, a couple things we know. We know it has to go up to 3. And then what do you guys think about the frequency? What's the b going to be here? Use your equation. 2, good, okay. Alright, so that means between 0 and 2 pi, 2 pi, you should see how many full curves? 2, right? Good, Carly, yes, because now if you're only going out to pi though, not 2 pi, you're not going to see all of them all, you only see one of them. The easiest way to kind of start this is to figure out using the period formula, 2 pi over b. Right. So what would the period be here? Pi, right? So that means it's going to take up to pi to see one full curve. Now, these don't have to be perfect. They just have to hit in like decent spots. Right? So if we know to get to pi, we need only one full curve here. Right? Sine curves start at 0. Right? They're 0 halfway through, and then they end at 0 when you see a full curve. So between the 0 and the pi over 2, what do we have to go up to? You think? 3. So again, just like make it halfway through. Doesn't have to be perfect. And then if we go all the way up, down, what do we have to go down to now? Negative 3. Good job. And then back around. So that would be just the one curve. Now, these curves go over and over and over and over again. Like, they just keep repeating. So if you're going the other direction, it just keeps going. But this time you have to go down first, and then back up and around.
So bad.
Right? Just make sure they don't look like sharp teeth. You know, you don't want little, like, chambers. Make them kind of rounded. Right? And then this is just your answer. 3 sine 2x. That's it. Now, could you have graphed this in a calculator and just used that? Probably. Let's see if our graph looks like this. Is it 3 sine 2x? 1 equals 3 sine 2x. So even if you guys want to graph it on here first, we can. Right? Just make sure they only wanted though, they didn't want this part of it shown. They only wanted from here negative pi over 2. So they only wanted you to see this part. And hopefully that looks like what we had, right? Going up to 3. Is this making sense? Sometimes I don't know if this is like too easy or you're bored or confused. Bored? Confused? It's weird. It is weird. A little bit of both. Alright. So I have a worksheet for you guys. It should not take you too long. It's pretty easy. A lot of it's just matching up graphs, kind of finding amplitude for your frequency. For the SCR formula, I don't normally put it as an R, and it's a total amount. That's good. R is right for the keyword. So I was right. That's good. Yep, this is good. Is there anybody else not going to be here tomorrow? Thankfully, the only difference is yeah, I mean, you can do it. I was playing around with my calculator. Just going to do like the same exact thing. Wait, by the time we get who's the It's all
Do
yeah.
you want to see what sign we should use?
Sure.
You too.
I have no data.
Oh, yeah, that's fine. All we did was started, we went over it very depth. Like, so it took us like 20 minutes to do this part. That's on mine. And then, we went over questions that we used in the corporate.
And then we hired one of
Yeah, I
Yeah, it's that's so there's a couple of that were really fast, so we went over like this one, do a little bit over right here, and we went over.
How's your curry this year?
So, yeah.
No, of course there is.
Good. Ross, after that. Thanks for running, buddy.
Yep, 1/3.
Chance through.
The number for F. Like this when they ran, it's a 1 over 3. That's gotta be everybody's favorite.
Here through.
Oh, Sean, thank you. Thanks so much.
Can't